In session 100, we're going to be identifying and describing what real numbers are. But before we get into that, let's take a look at the different categories that we've already addressed throughout this course. We've already dealt with counting numbers. Remember, counting numbers are numbers that you can count. Typically, when a young person starts learning math, they start counting with their fingers. So counting numbers start with the number 1, and they go on upwards, 2, 3, 4, and so on. Integers, on the other hand, also include all counting numbers, but integers also include the number 0, and they also include all the negative integers. If you want to think of it this way, negative whole numbers. So -1, -2, -11, 0, 6, now onto the positive end, 3. All of those are examples of integers. Rational numbers, and I'm not going to give you a lot of examples here, but remember, rational numbers are numbers that can be rewritten as the quotient of 2 integers. Irrational numbers are numbers that cannot be written as the quotient of 2 integers. So all the counting numbers are also included in the integers, but the integers contain more than just counting numbers. All the integers are contained within rational numbers. However, the rational numbers is greater than our integers. For example, remember, a rational number is just a number that can be written as the quotient of 2 integers. Is 22 over 7 a rational number? Sure it is. 22 is an integer, 7 is an integer, and the quotient of an integer is a rational number. However, the answer to this is not an integer. The answer is going to be some type of decimal number, 3.14 whatever. So we can see that integers are a part of the rational numbers, but there are a lot more rational numbers than there are integers. All the counting numbers are a part of the integers, but the integers contain a lot more than just counting numbers. Irrational numbers do not contain all the rational numbers, as well as integers and counting numbers. There is no relationship like that between rational and irrational. They are completely different sets of numbers from each other. However, here at the bottom, what we have are what are called real numbers. And as a quick definition for a real number is the set of all rational numbers and irrational numbers combined together. So if a number is rational, it's already a real number. If a number is an irrational number, it's also a real number. If it's a counting number, it's a real number. If it's an integer, it's a real number, and so on. So the real numbers are the set that is the combination of all rational numbers and irrational numbers combined. Now, an important property that real numbers have are called closure. What closure means, or closed means, is within respects to a particular operation. Well, in mathematics, we had 4 primary types of operation: adding, subtracting, multiplying, and dividing. Well, let's back up. First of all, we'll leave our real number category alone. Let's back up to counting numbers. For the counting numbers to be closed in relationship to addition, what that means is anytime you have 2 counting numbers and you add them together, your answer will be a counting number. Well, let's take 2 and 4. Both of those are counting numbers. If we take 2 plus 4 and add them together, we get 6. Is 6 also a counting number? It sure is. So counting numbers are closed with respect to addition. Well, what about multiplication? If we went 2 times 4, those are both counting numbers. What's our answer? Our answer is 8. Is 8 also a counting number? Yes. And that will be the same with any counting numbers. You take any 2 counting numbers together and you multiply them, you will get another counting number. However, that's not true with addition and division, or excuse me, with subtraction and addition. Subtraction and division. If we were to take 2 minus 5, 2 and 5 are both counting numbers, but is the resulting answer -3 a counting number? No. So counting numbers are not closed with respect to subtraction. What about division? What about 1 and 3? If we went 1 divided by 3, 1 and 3 are both counting numbers. Is our answer a counting number? No, our answer would be 0.333, which is not a counting number. So counting numbers are not closed with respect to division. Let's take a look at integers. Are integers closed with respect to addition? Yes. Doesn't matter what you take. If it's a negative number, a negative integer, a positive integer, or 0, if you take that integer and add it with any other integer, you're going to get an integer as an answer. Same with subtraction. If you take any integer and subtract it from another integer, you will get an integer as your answer. Same with multiplication. If you take any integer and you multiply it by another integer, your answer will be an integer. However, we get stumped when we try division. If we take one integer and divide it by another integer, for example, -2 divided by -11, is our answer another integer? No. Our answer here will be a fraction, or if we were to convert the fraction into a decimal, our answer would be a decimal. So integers are closed for addition, subtraction, and multiplication, but they are not closed for division. Skipping all the way down to real numbers are closed for all 4 operations together. They are closed for adding, subtracting, multiplying, and dividing. And one other key quality or component or property about real numbers is that they are ordered. And basically what ordered means is that every real number is greater than another real number, less than another real number, or equal to another real number. And all that means is every real number can be placed somewhere on a number line. All the rational numbers and irrational numbers combined make up the real numbers. Real numbers have closure in respect to addition, subtraction, multiplication, and division, and they also have order, which means that they all can be placed somewhere on a number line. That'll finish up session 100 on real numbers.